Okay, 1.7 transformations of functions. Okay, these are the parent functions that we went over yesterday, all except for the step function. The step function is right here, also known as a greatest integer function. That happens when I own one car until I own how many? All right, no cars until I own one, and one car until I own two. I have one kid until I have another kid, correct? It's like things you can't have halves of. Okay?
You can have half a car.
Sure, and it won't run. Okay, so this is called a constant function or a linear. Oh, this is a constant function, sorry. This is a linear function or the identity function, absolute value, square root, parabola, cubic, and reciprocal function. I guess reciprocal function wasn't on that sheet. I do expect you to identify all of these. If I gave you these and I said, tell me what they are, I would expect you to tell me linear, absolute value, square root, quadratic, cubic. Okay? So, just so you know. Those are the ones we will be moving, basically. Okay, I think we've already written these notes. Have we not? The H, the K, the A? Yeah. Okay, so I'm just going to go over it. A, first of all, linear is y equals mx plus b. Yes? I do not teach linear ever with an H and a K. I think it's completely ridiculous. Plot your y-intercept and count your slope, correct? That's all you need to do. Quadratic, A, and it can have a plus or minus in front of it, right? A, x minus h squared plus k. Absolute value, the same thing except with what function in the middle? Absolute value. Square root, the same thing except with a what in the middle? Square root. Cubic, the same thing except for what? Cubed. A determines how wide or narrow it is. H is left or right. K is up or down. Okay, and it says the critical value or the vertex here is at 0, 0. Yes? Mm-hmm. Vertex here, 0, 0. Here,
0, 0.
And here, 0, 0. And then we move our H and our K. This is nothing new, correct? Okay, you guys let me know when I'm good. The smaller A is, the wider. The larger A, the narrower. Larger, narrower.
Oh, now I remember H and K.
Smaller, wider.
That's a Q that I wrote.
We did this a lot last year. Our Algebra 2 curriculum, I think, sometimes goes overboard, but I think it's a really good prequel. And so you've done that already, so when I throw it at you again, it shouldn't be that hard to do. Bring it back, master it, we're done.
I don't remember this.
Am I good?
Mm-hmm.
It took me a minute.
Okay, so this is the same thing. I just want to let you know this is function notation with this f of x, and I touched the screen without touching my pen. Okay, this f of x is just called function notation. If it is outside the function, it is a k, correct? Mm-hmm. This is up, this is down. If it's inside the function, it is a h, and it is the opposite direction, yes? If it's negative, we go positive. If it's positive, we go negative. So down here is just an example. I'm just telling you this is function notation because it doesn't matter what function it is. Quadratic, cubic, square root, absolute value. This is the same setup. Am I good? Mm-hmm. Okay, the A, if it is a negative A, it is reflected over the x-axis. If the negative is on the x, it is reflected over the y-axis. Reflections over the y-axis, for some reason, are really, really difficult for people to, wrap their heads around. And so most people will try to do whatever they can to manipulate a function with the h, the k, and a reflection over the x without having to reflect it over the y. The only functions that it really has to be reflected over the y is like exponential, logarithmic, square root, those non-symmetric functions. And we'll work with those as we go through the textbook. Good. Okay. Sketching graphs with reflections. Okay. Square root, our parent function, looks like this. Yes? Okay, this is square root of x. Okay, this as a negative in front of the function, so it's reflected over what axis? The x. So instead of going up, it goes down. So this is negative square root of x. This one?
Is that a different color?
Yeah.
Someone?
It's purple.
Okay. Did you swear you like?
So purple and red are not very far from each other then. That's what you're telling me. Here, is that better? Now can you tell the difference between the two? Okay. So this one is reflected over what axis?
The X.
Nope, the x was the first. The y. So instead of going down, it goes backwards. The right side looks so nice, and then the left just falls apart. Okay, and now, what color can I do?
Green.
Green. Okay, now we've got this one. What's this one do?
It goes down.
Nope. This is a K, so it goes left. How many? 2. So 1, 2. So it starts here, and this is what?
Negative.
So what's it do?
Go down.
Reflects over the X, so it goes like this. So on the next to it, it says the domains. The first one, our parent function, its x is greater than equal to 0, because that's the only thing we can plug in there, right? Okay. Then when it's reflected over the x-axis, it's still greater than equal to 0, right here. When it's reflected over the y-axis, now we're not greater than 0, we are what? Less than 0, because we're everything to the left over here. And then this one's going to reflect over and then move left. So instead of 0, it is now what? Negative 2. Do you see how those things change the domain? Okay. Sometimes reflections do and sometimes they don't. Square root is one of those functions that is not symmetric, and so when you change it in any way, it's probably going to affect. Am I good? Okay, so we have this. And what they have is, this is the problem, and they have a bunch of points, and they have the original graph, and you're supposed to graph each one of these on here. Or on your paper, okay? We are not going to graph each one, but I'm just kind of explaining what the problem is asking for, okay? So, number 1, or A. What does A do to this?
You go down.
I go down 1. So does that affect X or Y?
No.
What?
No.
Does it X or Y? Y. It's it's a K, yes? K goes up and down. So that's the Y. So I subtract 1 from all my Y's. If you wanted to do this problem just by doing this, Y equals F of X minus 1. If you wanted to just say negative 2, 3, how did I get negative 2, 3? I took 1 from the Y, right? And 0, 2. And what would the next one be? 1, negative 1. And the next one? 3, negative 2. I would be okay if you did that, if you didn't want to graph them. The only thing, if you graph them, will it show you what it does, like how it affects the graph? Yeah. Do you get what this question is asking you for? Okay, which one do you want to do in there?
F.
F. Okay, so F tells you to take the function and take half of your answer. Well, which one is your answer, your X or your Y? You plug in an X, you get out a Y. So the Y is the answer, right? Okay, so we have Y equals 1/2 F of X. So all we're going to do, because remember F of X is the same as saying Y, isn't it? Okay, so all we're going to do is take half of the Y's. So it's going to be negative 2 what? 2. And then it's going to be 0, or how about 3/2? Okay. And it's going to be 1, 0. And 3, 1. Yeah, negative 1/2. Sorry. My brain just went bleh. And there I go. Did you get what this question is asking you to do? Questions?
On E, would it change your Y?
Well, on E, this is going to make my Y negative. If it's negative, it's going to be positive. If it's positive, it's going to be negative. And this one's going to do what with my X? No. No. It's X, so it's left or right. So it's right 2. The H is always the opposite direction. So this would be a negative Y and then plus 2 on your X's. You want to do that one? You do it, and then I'll do it. Check your work. I need to take the graph away. Did you get 0, negative 4, 2, negative 3, 3, 0, 5, 1?
Yeah.
Okay, write an equation for this graph. First of all, what kind of graph is it?
Absolutely.
So we're dealing with Y equals A X minus H plus K, correct? So my vertex was at 0, 0. Now where is it? 2, -4. Now this is my H and this is my K, yes?
Yeah.
I know my A is positive because it opens what direction? Up. Now I will tell you, it doesn't matter if you do your math right on this next step. It does matter if you do your math right on the next step. Your A will come out either positive or negative like it's supposed to. Okay? So the next step is we have to figure out what A is. So if we know what H is and we know what K is, we need to find an X and a Y. So is there a good X and Y on this picture? Give me a point.
-2, -4.
2, -4.
And then the Y is infinity.
Okay, but 2, -4 is my HK. I need a different, I need another point on this graph. 6, 0, you guys good with that? Okay, so we have 6, 0, and this is an X and a Y. So now I have an X, a Y, an H, and a K. Should I be able to solve for A?
Yeah.
Yeah, I just plug them in, right? So Y is what?
No.
0 equals A, the absolute value, X,
6
6,
minus 2.
minus 4.
I thought one of those was like plus, and then it was actually up or down or left or right. Oh wait, that's H, never mind.
Okay,
Never mind.
so absolute value I have to add 4, don't I?
Yeah.
And then 6 minus 2 is 4, so I have 4A. So I divide by 4 and A equals 1. So A is 1 and I have my H and a K. Should I be able to fill in this equation?
Yes.
Yes. So Y equals, do I have to put my 1 there? No. The absolute value of X minus 2 minus 4. I like to write them rather than graph them. That's my favorite because you just fill it in. I will tell you everything today should have an A of 1, but I guess don't just always check, because one that doesn't have, the biggest problem people have on the test is they don't check for the A. On the test, are you probably going to have an A other than 1?
Yes.
Yeah. So you can't assume that A is 1 unless you've counted your slope, because A in this case is the slope. But
Are we gonna do graphing on the homework tonight?
I don't see. I don't remember. Thank you. Okay. So what equation is this?
Square root.
Square root. So Y equals plus or minus A, the square root of X minus H plus K. Write it every time until you have it stuck, okay? So give me your H and your K. Oh, wait, 0, 0 went to where? I think 5, 5. Do you guys agree?
Yeah.
Okay, 5, 5. Now on this one, can I find another good point?
No.
I mean, I could guess, but I don't think. Is there a point given? No. Now, kind of rule of thumb is if you can't have a good point, you kind of assume it's 1. A is 1. If you can find a point, you need to calculate it. Okay? What's the other thing weird going on with this graph? It's reflected over the X or the Y axis?
Why? X.
The X. When it's instead of going up, it's going down, right? So it's reflected over X axis. Now I do expect you to write this information. This is your work on here, guys. That's your work. Okay? So let's fill it in. So Y equals, how are we going to show that reflection on the X axis? Negative right now, right? We're assuming it's a 1A because they didn't give me any other information, right? If they gave me another point, or if it was gridded and I could find another point, then I would calculate it. The square root of x minus 5 plus 5. It's that basic. Identify your h and k, your reflection, and calculate your a if you can. Make sense?
Yeah.
Okay, identify the parent function of each graph. Write an equation for each graph. So, what is my parent function here? The first one. What kind is it? Nope.
Linear.
No.
Cubic.
Cubic. Okay, what's the next one?
Absolute.
Absolute value. Square root. Okay, now on the first one, we have to assume that A is positive, correct? Yes? On the second one, watch. I know that A is positive. A is 1. There's no point other than the vertex, is there?
Yeah.
Okay. On the second one, I'm going to tell you I know A is 1. What is the slope from here to here? 2 over 2, which is...
One.
Are you okay?
I forgot to take my pills today, so I'm not screening.
Okay. So I know my slope is 1, so my A is 1. Okay? And then on this one, I do have a good point, so should I calculate it and make sure?
Yes.
Okay. So this one right here, what happened to the first one? What's my H and my K?
0.
How about 2, 0? Okay? So HK is 2, 0. So my equation would be Y equals, and it is positive because it's ending up. From left to right, it ends up. If it was negative from left to right, it would end what? Down. Okay, so x minus 2 cubed. And do I have to put plus 0?
No.
No. Okay. What's 2 going to be? Okay, so my H and K is negative 2, 0. So what's my equation going to be?
Y equals absolute value of x minus 2
Nope,
Plus 2.
plus 2. Because the formula is x minus h. Okay, so plus 2. And do I have to put plus 0?
No.
Nope. Okay, now the next one, what's HK?
1, 0.
0, 1. We better figure that one out real quick, huh? Okay, 1, 0. But we have to calculate.
0, 1.
So we're going to put 0, 1. How about 1, 0?
Is it 1 0 or 0 1?
Yeah, you're
It's 0. No, she said 0, 1. So I said 0, 1. And then I said, how about 1, 0?
Yeah, because you said 1, 0.
I'm so
This one is 0, 1. This one is 1, 0. Okay. So then I plug it into my equation to find A, right?
Yes.
Is A going to come out positive or negative, guys?
positive.
Negative. How do you know it's going to be negative? It's going down. The parent function goes up, doesn't it? So don't worry about plugging in the negative. Our math should show it's negative. Okay? So y is 0 equals A, the square root of x is what? 1 minus 0. And then k is 1. So I would subtract 1 to the other side. Yes? And 1 minus 0 is 1. The square root of 1 is 1. And 1 times a is 1a. So what is A?
-1.
-1. So if A is -1 and I have my H and my K, can I write my equation?
Yes.
Okay, so Y equals what?
-1.
Just root
Of H -1. Plus 1.
It's X minus H, but what's H? 0. So do I need to put it in?
No.
Do you want me to put it in so you can see it? Okay.
Plus 1.
Plus 1. Now, I wouldn't put that. I would write it Y equals negative square root of X plus 1. Is that the same thing? Yes. Okay, so I think today you're graphing those points. You're not doing much with just graphing it yourself. Okay? I'm sure that's the last slide. Oh, it's not. But, okay, let's keep going. Types of translations. Rigid, you guys, you don't really need to know this. Rigid does not change. It keeps the basic shape. Remember when we did rigid in geometry, we moved the whole circle left, right, up, down. We didn't make it wider, shorter. Rigid is your H and your K. Okay? Non-rigid is going to affect your A. Is it wider or is it narrower? Make sense? I'm not going to tell you to identify those. I'm not. Okay. So the example here is if I have the absolute value of X, which is the gray one, and then I have 3 absolute value of X, we've discussed that higher that A is, the narrower it gets. Yes? So that's the 3. And again, right here, when A is greater than 1, the rate of change is increased, causing the graph to narrow from the parent function. So if A is greater than 1, it is narrower than the parent function. That's what you need to get out of that slide. Am I good?
Yes.
Ainsley, am I good?
Yeah.
So guess what?
What?
If A is between 0 and 1, because we don't talk about like if it's negative or positive, the rate of change decreases, so it is wider than the parent function. So I have the gray is the absolute value of X, and the black is 1/3. Is it wider? There you go. Is that all stuff that we've discussed?
Yes.
Yes. See, aren't you glad you had this book in Algebra 2? Because now it's just a review.
I want to be in 3rd grade math again.
Oh,
Me too.
you could use some work on your fractions, so that'd be good.
I want some second grade
Yeah, but
math.
that's like
Okay,
1/2.
you guys good?
I don't remember doing anything.
Okay, so now we are going to identify the parent function. We're going to describe the secrets and transformations, and we're going to sketch the graph, and we're going to use function notation. It's a lot, guys, but don't worry about the directions, because those are the exact directions out of the book. There's like A, B, C through Z, it feels like. But watch. It's going to be really easy, okay? This 6, that looks weird there. What is it?
A.
No, it's not an A, because A is the coefficient, isn't it? Because it's A, F of X.
It's a K.
It's a K. Riley said it was a K first. I will identify that.
Yeah,
Okay, it is a K. So could I write it like this?
No.
Oops. Could I write it like that other than putting a parenthesis instead of an absolute value?
Yes.
Yes, I could. Do you know why they put it up front?
To confuse us.
No, they put it up front because this was negative, and they didn't want a negative in the front. Okay, does it matter where I put that K? No. Okay, so identify the parent function. What is my parent function?
0, 0.
No. F of x equals what? What is my parent function? What kind of graph is this?
Oh, absolutely.
Absolute value.
The V.
Okay, so this is A. Next one is describe the sequence of change. Well, that's just what's happening. We've done it already. So 0, 0, the vertex goes to where?
5, 6.
Negative 5, 6. What's this negative do? This one right here.
No, flips it.
Reflects it over what?
X-axis.
Okay, reflects over x axis. Is there anything else going on? Is there, the A is 1, right? So it's if it was 6, we'd say it was narrower. If it's 1, 6, we'd say it was what? Wider? Yes? Okay, so that's B. C says to graph it. Well, that should be pretty easy. So we go to negative 6, negative 5, 6. And we put a point, right? It's reflected, so instead of going up, it goes where? Down. Just a sketch. Okay, that's it. So D is the one that everybody's like, I don't know how to do D. It says function notation, yes? So here's my function. So we're going to use this. So we're replacing this with the absolute value.
Please report to.
So we have y equals negative f of x plus 5 plus 6. All I did was replace the absolute value with that f of. Okay? That's it. And now I just have this one. I'm glad we did the other one. This one, am I going to have to calculate an A because they gave me another point?
No.
Yes. Because this is an X and a Y, and my vertex is at 0, 0. If they give you another point other than the vertex, you have to calculate the X and Y.